Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using integrating factors. So let's get going. Problem solve x times 3y dx plus 2x dy plus 8y power 4 into y dx plus 3x dy equal to 0. Right? So we are given a differential equation x into 3y dx plus 2x dy plus 8y power 4 into y dx plus 3x dy equal to 0, right? We can write this as x into 3y dx plus 2x dy plus y power 4 into, I'll multiply these two terms with this 8. Then I'll get 8y dx plus 8 3s are 24x dy equal to 0, right? Now we can write this x as x into 1, right? Since x into 1 is x, right? And we can write this x as x power 0, and we can write y equal to y power 0 since y power 0 is 1, right? You can write x as x power 1, okay, not x power 0. And this 1 as y power 0. So you'll get into y power 0. So you can replace this x by x power 1 into y power 0. Likewise, here you're having y power 4. We can write this y power 4 as 1 into y power 4, right? Since 1 into y power 4 is again y power 4. And you can write this 1 as x power 0. You'll get x power 0 into y power 4. You can replace y power 4 by x power 0 into y power 4. Simply we'll write product of xy, that is product of x power some number into y power some number here. Okay, x power some number into y power number, x power some number into y power some number. Okay, fine. Now we'll write this x as x power 1 into y power 0 into 3y dx plus 2x dy plus, we can write this y power 4 as x power 0 into y power 4 into 8y dx plus 24x dy equal to 0. Consider the given differential equation as equation 1. Okay. We have written the given differential equation of x power a y power b into my dx plus nx dy plus x power c y power d into py dx plus qxdy equal to 0 form, right? See, we have reduced this into this form where a equal to 1, b equal to 0, m equal to 3, n equal to 2, c equal to 0, d equal to 4, p equal to 8, q equal to 24, right? Which are constants. So consider this reduced equation as equation number 2, where a equal to 1, b equal to 0, c equal to 0, d equal to 4 and m equal to 3. Just by comparing these two, we'll get the constants. I mean the unknowns, otherwise the values of unknowns we can say. Okay, n equal to 2, p equal to a, q equal to 24, right? Since the given differential equation can be written of this form, so here we'll solve this equation using integrating factor x power alpha and y power beta. So here we need to find alpha and beta. Okay, so I'll solve this using two methods in two different videos. Okay, fine. So after finding alpha and beta, we'll substitute alpha and beta in this integrating factor, and later we'll multiply this integrating factor to the given differential equation in order to make the given differential equation an exact equation. and later we'll find the general solution to the given differential equation using the general solution formula of an exact equation. Okay, let's see that. See, here we can check whether the given differential equation is exact or not. We'll check whether it is exact or not. We'll do some verification later after solving the problem. Okay, fine. Let x power alpha y power beta be the integrating factor. Now, multiplying equation 1 by integrating factor x power alpha y power beta. Okay, let's multiply the integrating factor to the given differential equation, that is equation 1. Okay, this gives us x power alpha y power beta into x into 3y dx plus 2x dy, or just multiply it. 3xy dx plus 2x into x square dy plus 8 y power 4 into y power 5 dx plus 3 8s are 24x y power 4 dy equal to 0, which gives us 3 into x power alpha into x, y power beta into y into dx plus 2 into x power alpha into x square into y power beta dy plus 8 x power alpha y power beta into y power 5 dx plus 24 x power alpha into x into y power beta into y power 4 into dy equal to 0. Right? Now this gives us 3 into x power alpha into x power x power alpha into x. See, you can write this x as x power 1, base are equal, add the powers, you'll get x power alpha plus 1. X power alpha plus 1. Y power beta into y is, you can write y as y power 1. Just add the powers, you'll get y power beta plus 1. Into dx plus 2 into, add the powers, alpha plus 2. Y power beta into dy plus 8 x power alpha into y power, add these two powers, you will get beta plus 1, y power beta plus 5, into dx plus 24 x power alpha into x power 1 gives x power alpha plus 1 into y power beta into y power 4 gives y power beta plus 4. We'll just add the powers since bases are equal, so we can add the powers, right? Equal to 0. Now let's take dx common from the first term and the third term, and dy from second term and the last term. Okay, we'll get 3 into x power alpha plus 1 y power beta plus 1 into dx, plus we need to take dx common, right? So you'll get into dx plus, now take dy common from these two terms, we'll get 2 x power alpha plus 2 y power beta plus 24 x power alpha plus 1 y power beta plus 4 into dy equal to 0. right? Or I'll just write it again. Right? Which is of mdx plus ndy equal to 0 form. See, the given differential equation can be written in mdx plus ndy equal to 0 form, right? In order to consider so many equations of this form, so I'll consider the given differential equation m1 dx plus n1 dy equal to 0 form, okay? Because we need to find whether, we need to check whether the given differential equation is exact or not, right? So we'll write the given differential equation of this form, that is m1 dx plus n1 dy equal to 0. So I'll consider the reduced equation as m2 dx plus n2 dy equal to 0, okay, for my convenience. Otherwise you can just consider it as m dx plus n dy equal to 0, nothing is wrong in it, okay. Consider as equation number some asterisk, okay. This equation of the form mdx plus n dy equal to 0. So here asterisk, equation asterisk is exact if dou m by dou y equal to dou n by dou x, okay. For m equal to 3x power alpha plus 1 into y power beta plus 1 plus 8x power alpha y power beta plus 5, and for n equal to 2x power alpha plus 2 y power beta plus 24 x power alpha plus 1 plus y power beta plus 4. Right? Then partial derivative of m, 3x power alpha plus 1, that is m equal to, we are having 3x power alpha plus 1 y power beta plus 1 plus 8x power alpha plus into y power beta plus 5 equal to dou by dou x of n, 2x power alpha plus 2 y power beta plus 24x power alpha plus 1 y power beta plus 4, right? So in the LHS part we need to find the partial derivative of terms with respect to y. So here x is treated as constant. In the first term x power alpha plus 1 is constant, in the second term x power alpha is constant, and here we need to find partial derivatives of the terms with respect to x. So here y is treated as constant, so y power beta and y power beta plus 4 are constants, right? Now we can write this as 3x power alpha plus 1 into dou by dou y of y power beta plus 1 plus 8 x power alpha into partial derivative of y power beta plus 5 with respect to y equal to 2y power beta into partial derivative of x power alpha plus 2 plus 24 y power beta plus 4 into partial derivative of, it's x, okay, partial derivative of x power alpha plus 1 with respect to x. This becomes 3x power alpha plus 1 into Partial derivative of y power beta plus 1 with respect to y is beta plus 1 into y power beta plus 1 minus 1, okay, plus 8 x power alpha into partial derivative of y power beta plus 5 with respect to y is beta plus 5 into y power beta plus 5 minus 1 equal to 2y power beta into partial derivative of x power alpha plus 2 with respect to x is its alpha, okay, alpha plus 2 into x power alpha plus 2 minus 1 plus 24 y power beta plus 4 into partial derivative of x power alpha plus 1 with respect to x is alpha plus 1 x power alpha plus 1 minus 1. This gives us 3x power alpha plus 1 into, okay, beta plus 1 into y power plus 1 minus 1 gets cancelled, you will get y power beta plus 8 x power alpha into beta plus 5 into y power beta plus 5 minus 1 gives plus 4 equal to 2y power beta into alpha plus 2 into x power alpha plus 2 minus 1 gives plus 1 plus 24 y power beta plus 4 into alpha plus 1 into x power plus 1 minus 1 gets cancelled and you will get x power alpha, right? You can write this as 3 into beta plus 1 into x power alpha plus 1 y power beta plus 8 beta plus 5 into x power alpha into y power beta plus 4 equal to 2 alpha plus 2 into x power alpha plus 1 y power beta plus 24 alpha plus 1 into x power alpha y power beta plus 4. So if you notice, we are having x power alpha plus 1 y power beta in these two terms and x power alpha y power beta plus 4 in these two terms, right? Let's equate the terms involving x power alpha plus 1 y power beta and equate the terms involving x power alpha and y power beta plus 4. I mean equating the equations of, okay? And x power alpha y power beta plus 4. So firstly we are going to equate the equations of x power alpha plus 1 and y power beta. You will get 3 times beta plus 1 equal to 2 times alpha plus 2, right? And by equating the equations of x power alpha y power beta plus 4 gives 8 times beta plus 5 equal to 24 times alpha plus 1, right? This gives us 3 beta plus 3 equal to 2 alpha plus 2 2s are 4, or we can write this as 2 alpha plus 4 equal to 3 beta plus 3. Now bring this 3 beta to LHS and take this 4 to RHS, then we'll get 2 alpha minus 3 beta equal to 3 minus 4, which gives us 2 alpha minus 3 beta equal to 3 minus 4 is minus 1, right? And here you'll get 8 beta plus 8 5s are 40 equal to 24 alpha plus 24 into 1 24. or we can write this as 24 alpha plus 24 equal to 8 beta plus 40. Now bring this 8 beta to LHS and take this 24 to RHS. We'll get 24 minus 8 beta equal to 40 minus 24, which gives us 24 alpha minus 8 beta equal to 40 minus 24 is 16, right? Or here you can take 8 common from these two terms, then you'll get 8 times 3 alpha minus beta equal to 16. Now take this 8 to RHS, then you'll get 3 alpha minus beta equal to 16 by 8. 8 ones are 8 twos are, which gives us 3 alpha minus beta equal to 2. Now consider this equation as equation number A and this one as equation number B. By solving A and B, we'll get the values of alpha and beta. Okay, let's solve these two equations to find alpha and beta here. Now I'm going to solve these two equations. See, I'm going to cancel the terms involving beta here. So what I need is, I need a plus 3 here. Okay, so what I'll do is, I'll multiply the whole equation with minus 3 or just multiply it with 3. Okay, we'll get solving A and B. First equation, that is equation A, is 2 alpha minus 3 beta equal to minus 1, and we'll just multiply this equation with 3, then you'll get 9 alpha minus 3 beta equal to 3 twos are 6. Now change the signs in the second equation. Okay, so here minus 3 beta plus 3 beta gets cancelled and you'll get 2 alpha minus 9 alpha gives minus 7 alpha equal to minus 1 minus 6 gives minus 7, right? Or 7 alpha equal to 7, then alpha equal to 7 by 7, which is equal to 1. Therefore alpha equal to 1. We got the value of alpha. Now we need to find the value of beta, right? We have equation A, 2 alpha minus 3 beta equal to minus 1, right? Or we can write this as 2 alpha plus 1 equal to 3 beta. Simply we'll bring this minus 1 to LHS and take this 3 beta to RHS, then you'll get 2 alpha plus 1 equal to 3 beta, or we can write this as 3 beta equal to 2 alpha plus 1. Since we are having alpha equal to 1, the value of alpha, right? Then the above equation becomes 3 beta equal to 2 into 1 plus 1, which gives us 3 beta equal to 2 into 1, 2 plus 1, which gives us 3 beta equal to 3, then beta equal to 3 by 3, which is equals to 1, right? Therefore beta equal to 1. So we got the values of alpha and beta, right? Alpha equal to 1, beta equal to 1. Therefore alpha equal to 1 and beta equal to 1. We got the values of alpha and beta here. Now we can find the integrating factor to our problem. Since we got the values of alpha and beta, so the integrating factor becomes x power alpha y power beta equal to, since we have alpha equal to 1 and beta equal to 1, then the integrating factor will be x power 1 into y power 1, which is xy. So we got the integrating factor. Now multiplying this integrating factor to the given equation, the given equation becomes exact, right? By multiplying the integrating factor to the given differential equation. The given differential equation is reduced to exact equation. Fine. Now multiplying integrating factor xy to the given differential equation or equation 1. Then we'll get xy into first equation, x times 3y dx plus 2x dy plus 8y power 4 into y dx plus 3x dy equal to 0. This becomes xy into 3xy dx plus 2x square dy plus 8y power 5 dx plus 8 3s are 24 xy power 4 dy equal to 0, right? Which gives us 3x square y square dx, 3x into x square, y into y square dx plus 2 x into x square x cube into y dy plus 8 x y into y power 5 is y power 6 dx plus 24 x into x square, y into y power 4 gives y power 5 into dy equal to 0, right? Now take dx common from these two terms and dy common from these two, right? Then you'll get 3x square y square plus 8x y power 6 into dx plus 2x cube y plus 24x square y power 5 into dy equal to 0, right? Consider it as equation number 3. Now let's see whether equation 3 is exact or not. If see this is of the form mdx plus ndy equal to 0 for m equal to 3x square y square plus 8x y power 6, and for n equal to 2x cube y plus 24x square y power 5. If the partial derivative of m with respect to y equal to partial derivative of n with respect to x, then we can say that the reduced equation, that is the equation 3, is exact. Okay, let's check it out. This is of the form mdx plus ndy equal to 0, where m equal to 3x square y square plus 8x y power 6 and n equal to 2x cube y plus 24x square y power 5. Okay, now we are going to find the partial derivative of m with respect to y, and later we'll go for partial derivative of n with respect to x. So this is equals to dou by dou y of m 3x square y square plus 8x y power 6. So here we need to find the partial derivatives of these two terms with respect to y. So here x is considered as constant. So here x square and x are constant. So we'll write it as 3y square into partial derivative of, here x square is constant, right? So you'll get 3x square into partial derivative of y square with respect to y plus constant 8x into partial derivative of y power 6 with respect to y. Here 3x square is constant, here 8x is constant, right? So this gives us 3x square into partial derivative of y square with respect to y is 2y plus 8x into partial derivative of y power 6 with respect to y is 6y power 5, which gives us 3 2s are 6 x square y plus 8 6 are 48 x y power 5. Okay, let's now find the partial derivative of n with respect to x. Here we need to find partial derivative with respect to x, so y is treated as constant. So you'll get here y is constant, and in the second term, okay, 2 and y are constant, and here 24 and y power 5 are constants. Okay, so you'll get 2y into partial derivative of x cube with respect to x plus constant 24 y power 5 into partial derivative of x square with respect to x. This gives us 2y into partial derivative of x cube with respect to x is 3x square plus 24y power 5 into partial derivative of x square with respect to x is 2x, which gives us 2 3 is 6 x square y plus 24 2s are 48 x y power 5. So you got the same answer. It shows that partial derivative of m with respect to y equal to partial derivative of n with respect to x, right? From this we can say that equation 3 is exact. Therefore, partial derivative of m with respect to y equal to partial derivative of n with respect to x equal to 6x square y plus 48x y power 5, which shows that equation 3 is exact. Equation 3 is exact, right? Now we'll find the solution to the given differential equation using the general solution to this equation 3, which is given by the formula of the general solution of exact equation. The general solution is given by integral over m dx treating y as constant plus integral of terms of n free from x into dy equal to c. For m equal to, we'll consider the m and n of the reduced equation, since the reduced equation is of the form mdx plus ndy equal to 0, where m equal to 3x square y square plus 8x y power 6 and n equal to 2x cube y plus 24x square y power 5. Okay, for m equal to 3x square y square plus 8x y power 6 and n equal to 2x cube y plus 24x square y power 5. Okay, so we'll find each term or each integral separately for our convenience. I'll begin with the first one. We have m 3x square y square plus 8x y power 6 into dx. Here we have to treat y as constant, right? So y square is treated as constant, y power 6 is treated as constant, and also 3 and 8 are constants, right? We'll write this as 3 y square into integral x square dx plus 8 y power 6 into x dx, which gives us 3y square into integral x square dx is x cubed by 3 plus 8 y power 6 into integral x dx is x square by 2, which gives us x cube y square plus 4 x square y power 6. Okay, so this is the result obtained from the first integral. Okay, x cube y power 6, sorry, it's 2, right? Y square plus 4x square y power 6. Now coming to the second integral. Terms of n free from x into dy. For n equal to 2x cube y plus 24x square y square. So just identify the term which is free from x, right? In both the terms we are having x, so there is no such free term which is free, there is no such term which is free from x, right? So we'll get integral of terms of n free from x into dy is 0. So the result obtained from the second integral is 0, right? Now coming to the general solution. Therefore, the general solution is the result obtained from the first integral is x cube y square plus 4x square y power 6 plus the result obtained from the second integral is 0 equal to c. Then x cube y square plus 4x square y power 6 equal to 0 is the required solution, right? Therefore, x cube y square plus 4x square y power 6 equal to c is the required solution. This completes the problem. Okay, fine. Now let's verify that given differential equation is exact or not. Okay, so this is the required solution, or we can just take x square y square common from these two terms. Okay, then we'll get x square y square of x plus 4y power 4 equal to c. We are given differential equation x into 3ydx plus 2x dy plus 8y power 4 into ydx plus 3x dy equal to 0, right? We can write this as 3x y dx plus 2x square dy plus 8y power 5 dx plus 8 3 is a 24 xy power 4 dy equal to 0, right? Now let's take dx common from these two terms and dy common from these two terms. Okay, we'll get 3xy plus 8y power 5 into dx plus 2x square plus 24xy power 4 into dy equal to 0, which is of mdx plus ndy equal to 0 form, right? For m equal to 3x plus 8y power 5 and for n equal to 2x square plus 24xy power 4, right? If the partial derivative of m with respect to y equal to partial derivative of n with respect to x, then we can say that the given differential equation is exact. If it is not equal to 0, then we can say that it is non-exact. Okay, let's find partial derivatives of m with respect to y and partial derivative of n with respect to x. Okay, I'll begin with partial derivative of m with respect to y. This equals to dou by dou y of m 3xy plus 8y power 5. Since we need to find partial derivative with respect to y, so 3x is treated as constant or x is treated as constant. Okay, and here 8 is constant, so we'll write this as 3x into partial derivative of y with respect to y plus 8 into partial derivative of y power 5 with respect to y, which gives us 3x into partial derivative of y with respect to y is 1. 3x into 1 plus 8 into partial derivative of y power 5 with respect to y is 5y power 4, which gives us 3x plus 8 5s are 40 y power 4, right? Let's now find partial derivative of n with respect to x. Partial derivative of n with respect to x for n equal to 2x square plus 24x y power 4. Since we need to find partial derivative with respect to x, so here y is treated as constant. In the first term 2 is constant, and in the second term 24 y power 4 are constants, right? So we can write this as 2 into partial derivative of x square with respect to x plus 24 y power 4 into partial derivative of x with respect to x, which gives us 2 into partial derivative of x square with respect to x is 2x plus 24 y power 4 into partial derivative of x with respect to x is 1, which gives us 2 2s are 4x plus 24 y power 4. Just by observing these two, we can say that partial derivative of m with respect to y is not equal to partial derivative of n with respect to x. So we can say that the given differential equation is not exact. Since it is not exact, so we have applied integrating factor to find the general solution to this given equation, right? Fine. So we have solved the differential equation using integrating factor in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.